Hey everybody, today in this video I am going to quickly review the SINE parent function. Then we are going to talk about the shape that the SINE function has by default, and then we are going to talk about the shape it takes when we just make the a value or the leading coefficient negative. And we're going to look at those two sketches, and then we're going to dive in pretty deep and we're going to do transformations of all sorts right off the bat. And we're going to talk about a formula for the period of a sine wave, and we will go over the amplitude, the period, the shifts, which would be called either a phase shift, which is the horizontal shift, or a vertical shift, moving it up or down, which will move your sinusoidal axis. So let's get started. First and foremost, we need to know the parent function and what its graph looks like, and really how to come up with that graph if in the future, a year from now, 2 years from now, you are doing an example, it involves the SINE function and you just forgot what it looked like. So how would you do that? Y equals sine x. Y is my output, x is my input. X, the input, represents an angle, and we are going to use radians. You should be using radians basically all the time, okay? The radians that we check in on, and this is just the part you have to more or less remember by yourself, the radians you check in and evaluate sine at should be the quadrantal angles. Those are your best bet for getting an idea of what the graph looks like. So in your mind, in a thought bubble above your head, you are going to imagine the unit circle. You shouldn't need to draw it. I'm drawing it for now. You shouldn't need to, but we're going to imagine starting at 0 and going all the way around until 2 pi. That is one full cycle. One full cycle is the shape that the sine wave takes as we go through the x values of 0 until 2 pi. That shows one cycle of the sine wave. The period is how long it is. The length from 0 to 2 pi is 2 pi, okay? So the cycle will be the outputs, the collection of outputs, the shape this graph takes between 0 and 2 pi. Really, I suppose we could really pick up from pi over 2 all the way around until 5 pi over 2. But for this lesson, for this class, we're just going to talk about the cycle being from 0 to 2 pi, the shape that it takes, and the period by default of the parent function will equal 2 pi. So over here, I'm going to put a little note, P equals period. You might want to write down that it is the length of one full cycle. Okay, I'm not going to write that right now, but you should probably write that down. It's equal to 2 pi, but if we had a different example, the period, which is on your x-axis, will be influenced by horizontal stretches or compressions. The length of it doesn't change based on a phase shift. If we shift left or right, the length doesn't change. The whole thing sort of just picks up and scooches left or right. The only thing that would change the length of it is a horizontal stretch or compression. So that B is inside that crazy house where everything sort of works backwards. Then what we do, instead of multiplying 2 pi by whatever B is, since it works in a reciprocal way, we use 2 pi over B. We divide by B and it takes care of that for us. So if we had a 2 for our B value, 2 is greater than 1. We took notes on the fact that when 2 or B is a number like 2 greater than 1, that actually causes a horizontal compression, not a stretch. Even though the number is bigger than 1, it actually compresses it. And if you think about it here, if I plugged in 2 pi over 2, my new period will be pi. That means that my whole shape of my cycle, instead of happening between 0 and 2 pi, well, now it's being squeezed and compressed, and it's happening between 0 and pi. So sine and cosine. This is going to be a great opportunity for you guys to really understand these horizontal stretches and compressions and a lot of the transformations on a new level. So that is a little formula that we're going to use on examples that have transformations, okay? So you might want to maybe put a little happy cloud around it and save that as a separate part of your notes. So this example, the period is 2 pi, the parent function. However, and also if you think about it, b equals 1, so 2 pi over 1. But we're going to change that b value from time to time. We're going to need that equation. Okay, next thing. If we fill in our quadrantal angles from beginning to end, we have to finish and start at a coterminal angle. So I should have tick marks at 0. My last tick mark, I like to draw the last one first, and I'll explain why, is 2 pi. The middle one, which is kind of easy to eyeball where the middle is, that's pi. Then the middle of each of those. This just helps that my spacing is more even instead of it getting a little messy. And it's important that they're all the same size, okay? So these are each a quarter, important, these are each a quarter or a quadrant of a full period or of the full cycle, okay? So this is 1/4 of the whole thing. Repeat, 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 4 quarters make a whole. Next, we're going to evaluate sine at each of these quadrantal angles. Sine is the y value on the unit circle. So what do I need to do? Well, starting here, what is the sine at 0 radians? The way we use the unit circle to help us is the x and y coordinates of the points we associate with each of the angles give us x is cosine, y is sine. Give us the cosine and sine. If you need to understand where that comes from again, you need to go back and go over the unit circle lessons. Sine at 0 is 0. I have a point right there. Sine at pi over 2 is 1. That's also the biggest answer I can possibly get when I evaluate sine at an angle. Sine at pi is 0 again. Sine at 3 pi over 2 is -1, and that is actually the smallest answer I could get for the sine of an angle. And then sine of 2 pi should be the same as sine of 0, so I get 0 again. Now we connect these dots, but they're going to be smooth. If you really, really wanted to create more points, you could do 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6 pi over 6 is pi, 7, 8, 9 pi over 6, 10, 11, 12 pi over 6. But that's just a lot of points to include, really isn't necessary. Also, sine of pi over 6, that one's not so bad, it's a half, so it kind of gives you an idea of where those points are. Over here would be 5 pi over 6, it's a half. Here, 7 pi over 6 is -1/2. 11 pi over 6 is also -1/2. You could kind of gauge where those are, but where's rad 3 over 2? I mean, it's about 0.87, I guess. It's just not necessary. As long as you remember that it will make these little curves. So this first part, really the first half of the sine wave is concave down, looks like a frown. And the second half of my sine wave right here of one cycle, concave up, looks like a cup. Now really, that's not the beginning and the end of the graph. We talked about this being periodic, cyclic. It repeats itself over and over and over. So this wave is just going to go on forever and ever and ever. And sorry if it's a little bit blurry, I'm sorry. And we just worry about when we graph one cycle and we choose that cycle to be near the origin, and then we use transformations to scooch it around left, right, up, down, a vertical stretch or compression, or a horizontal stretch or compression, or perhaps some reflections. The reflections we'll have more conversations about as they relate to something called an odd or an even function, but one thing at a time. So that right there is your parent function. So another important formula that I like to use is after P comes Q in the alphabet, right? LMNOPQRS, right? So we're going to find Q after we find P. And if the period is whatever that turns out to be, another important thing is 1/4 of the period. So that's another formula that we want to use. We also would like to find our first tick mark. First tick mark. The first tick mark is also important. The first tick mark is always going to be found by using h in your transformation equation. Y equals a times the sine of b x minus h plus k. So quarter of the period, there's the formula. It's just literally 1/4 of the period. The first tick mark will be at h. So if it's like -5, the first tick mark is at 5. If it's minus pi over 2, the first tick mark will be at pi over 2. Okay? You could also find it by setting this entire parenthesis equal to 0. I'll talk more about that as we have examples in front of us and when and why sometimes it's good to do that. After that, after you find the first tick mark, wherever it is, that will take care of your horizontal shift or phase shift. You are going to add the quarter period to it 4 times to get the other 5 tick marks. So that's the first tick mark. Then this one will be h plus q. Then the next tick mark will be h plus q plus q. Next will be h plus q, meaning the one before it, so I'll underline like this, plus another q. And then last but not least, h plus 3 of these, because we already added it 3 times, plus 1 more. And that's how you get all 5 of your tick marks. So this is the first, second, third, fourth, and fifth. You have 5 tick marks, and these each spaces in between, all right? We have 4 of them, and that should make sense. These 4 spaces are symbolic of the 4 quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4, okay? All you do then is you take this shape, a 0, we could call it a 0, it's going to be right here on it won't always be on the x-axis if it moves up or down. It's on the sinusoidal axis or midline. We'll talk about that in a minute. But you draw in your shape. If it's positive, you'll draw your shape from a 0 to a max to a min to 0, max, 0, min, 0. If it's positive, it takes that shape. If it's negative, y equals negative sine x. That's a vertical reflection, so your graph will just flip over the x-axis or over its midline, and it'll just have that shape instead, and this is still your sinusoidal axis, midline, sometimes your x-axis, whatever. So I'll try to color coordinate in a minute. So that takes care of h, that takes care of the b value. Now what about a and what about k? All right, k tells you where the middle of your graph is. So the line dashed y equals k is your midline, if you want the simpler word, or it's the sinusoidal, fancy word, axis. Oops. So put these clouds around all this important stuff, okay? So that's important. These are important. Again, I'll try to color coordinate a bit. If you get this all written and really, really look at it, and maybe rewatch this after we do an example, I really think you'll piece this all together. Okay, first, second, third, fourth, fifth tick marks. Sinusoidal axis uses K. The Q involves the B because it comes from P, the period. We took care of H. Last thing, A. A is for amplitude. Think of, Sesame Street or something. A is for amplitude. So the A, really, if you take the absolute value of A, word again, A for absolute value, the A tells you how high up or how far down your max and mins are, okay? So as you draw your sine wave, in this case, sine, next time it could be cosine, we'll talk about that. We make sure we make it nice, smooth, and curved. If it's positive, it has that shape. If it's negative, it takes on, If it's negative, it just flips that way. But the distance in here, so where can I write that without running out of room? This distance from here to here, how far is it from the midline to the max, will be the absolute value of A in distance, okay? And then here as well. So I will try to draw it with the highlighter and show that in a minute. So let's look at each of these. So if I wanted to look at the B value, where does that come into play when we deal with the period? Okay. So the B value affects the period. The period, we'll see if I run out of highlighter colors. The period is going to affect the quarter period, okay? That's going to affect the quarter of the period, of course, they're involved. From there, the quarter period is what helps us label our tick marks. Oh, another thing, when we're doing all this, you want to make sure you just don't reduce, okay? I know usually it's like, reduce your fractions, and everyone's always yelling at you to reduce your fractions. This time, leave it. It makes it a lot easier to analyze with your common denominators and whatnot if you just don't reduce, and you could really see, like, do my answers make sense? Are my tick marks evenly spaced? So on and so forth, and it'll be a little nicer to look at that way, okay? H, sorry, this highlighter, I'm really holding on to it. It's pretty dried out. I should really throw it away, but I like this color green better than my other markers. There you go. So the first tick mark will be at H, but remember that sign is backwards, so it's minus something, whatever that something is. So if it's plus, it's negative. There's the H. We can also throw in okay. These are, you don't have to say both words, sinusoidal axis or midline are both fine. It's at y equals k. And make sure you remember that lines like a sinusoidal axis, lines like something underlying that helps you draw your graph, asymptotes, those should be dashed. If they're solid, it implies that it's really part of your graph, and you don't want to make those types of things solid, okay? Here you don't necessarily see it because it's maybe on top of your x-axis, but it is still there. We can also include, what other color can I use? I think I have a purple. Okay, there's A, and that is this distance in here. In this case, A was equal to 1, or the absolute value of 1, because we had an invisible 1 out in front right there. Okay, same idea. There, there, there. And this is another place where we would find A. So it tells you how high or low you go to find those extreme points on your graph. So this right here, absolute value of A is kind of squeezed in there. So I'm going to put a little note, absolute value of A, that's an A, sorry if it looks like another letter, my tail's a little long, is distance above / below y equals k, where max and min are located. Okay, now while that's k, you could also say that, this over here, well, that's the x coordinate, the y coordinate is up whatever k plus the absolute value of A is. So k, since that's your midline, you're going to go in total as a y value, you're going to go up that k value plus the absolute value of A. And down here at the bottom, okay, you're going to go well, maybe not up, because you might go down, because what if it's negative? So vertically, so really it should just be vertically. Your vertical shift. And then this guy right here is k minus the absolute value of a. If a is negative, minus negative would be plus, and it would kind of mess things up a bit. So those are really the y values of the extrema, or maximum and minimum points in these examples. And I mean, with k I did pink. I guess I could still use, I should maybe just still use purple for this. I'll try to use a lighter purple, kind of. I don't know how much that's even showing up. But lots of information here. Color coordinate, do what you got to do. But we're going to do an example now after this. And so you could just click through to that video. And I hope that you took notes and can use all of these notes to get your example done. Okay? So if you copied all this down, you think you can use it, maybe for now you still put a thumbs down on the video because you're like, I don't think I could do this. Maybe after you watch the next video, and you're like, oh, I can do this. Maybe you come back, give it a thumbs up, or give that one a thumbs up, as telling yourself you know how to do it. So document for yourself anything I post with a thumbs down if you still need to work on that. Okay? Your own personal checklist. I'll see you in the next video.